In this video, I'm going to be talking about Ohm's law. This is part of what I assume is presumed knowledge for IB physics. I'm doing this to help some of my students who might need a refresher course since maybe they haven't seen electricity in a long time. Please read the success criteria of what I plan to accomplish in this video. Okay, so in this picture you can see I've got a simple circuit. There is a source here, a cell, I have a resistor, and a switch just to control the current. In this case, all of the potential difference that's given to the electrons by the cell is going to go to the resistor. We're going to assume that the wires are perfect and that no potential difference is given to the electrons to flow through the wire. For those of you who are not familiar, Ohm's law is just this: resistance equals voltage divided by current. I'm going to use this circuit to be able to collect the data I need in order to calculate the resistance of this particular resistor. So what that means is I'm going to have to get the values of the voltage and the current. And in order to get this relationship, I'm going to have to have an independent variable of either the voltage or the current. In these kind of setups, it's usually easier for us to change the voltage. When we do this in the classroom, we usually have a power source that we can manipulate as our independent variable. So in this case, I will change the voltage and I will measure the current. So current will be our dependent variable. Using the PhET simulation, where I got all these pictures from, and I'll put a link in the details of this video, here's the values I have for my resistor. So I've created with that data a current versus voltage graph using Logger Pro. So one of the things when we make our graph, we should be putting our independent variable on the x-axis and our dependent variable on the y-axis. In my graph, you can see that I have a linear relationship. Actually, it's directly proportional, and I can say that because it's a straight line that goes through 0, 0. And since this relationship isn't changing at all, as you can see with the straight line, that means I'm going to be able to have a constant resistance. So here's the same graph, but now I've put voltage versus current. And a lot of the times you'll see graphs that look this way as a V versus I graph rather than I versus V. If you see, since I have a constant gradient, a lot of the times people are going to say, since R equals V over I, if I use the gradient of this line of best fit, I would then get the resistance. But, and there usually is a but, this is only true in this case because we have a constant resistance. Resistance is defined as the ratio of volt potential difference per current going through the resistor. So it's only because this is a constant value that this is true. If the resistance was actually defined as the gradient, then the equation should have the little deltas in front, the rate of change of current. It's not. It's just the value of the potential difference versus the current. So that brings us to our next part, the fact that not everything obeys Ohm's law. In fact, if a resistor does obey Ohm's law, we call it ohmic. If I had the voltage versus current graph and it looked like this green line here, it would have a higher resistance compared to this blue line, which would have a lower resistance. Notice at the same voltage, the higher resistance creates a much lower current than the lower resistance. Now, if we talk about ohmic resistors, there must be some things that are non-ohmic. For example, a filament lamp. If I did the same experiment with a filament lamp, I'd probably get a line looking like this. Notice that the gradient is changing, which also tells me that that ratio of voltage versus current is changing. In fact, the filament lamp will increase. The last graph I have here is for a diode, and that is not expected for you to know as presumed knowledge, but it will come up in topic 5. Hopefully you do know that a diode will only allow electricity or current to flow in one direction, so it's going to have its own very characteristic VI graph. So take a moment again to read the success criteria. Hopefully this video will now let you say yes to all of those bullet points.